So if we look at stars and we want to know, so if we're talking about the life cycle of stars, I'm just going to go through the stages. So the first thing, you got the Big Bang, about 13.8 billion years ago. All the matter and energy is condensed in small space, creates a lot of pressure, and that pressure is released in the form of the Big Bang explosion. So now we have all these hydrogen, helium atoms floating around in space. Some areas are more dense than others, and those dense areas have a lot of hydrogen. And those hydrogens then are starting to condense, they spin, get hotter, hot enough for nuclear fusion. So now we have nuclear fusion and we have stars being made. So if we think of our sun, which is a main sequence star, they can live for billions and billions of years, and our sun now has been around for about 5 billion years, scientists estimate, and has another 5 billion to go before it actually will burn off all the hydrogen fuel. So what about larger stars? Massive stars that maybe are 10 times as big as our sun. They do the same thing, but since they're bigger, they generally do not, they usually go through the gas a lot faster. So they use up the gas faster. They're like gas guzzlers, like cars. The big cars tend to use more gas than smaller, more economical cars. So here we have a picture of the inside of a large star. And it's really in layers. So the larger it is, the more layers it has. Helium. So helium then is the next layer in. Then we have helium. And these fuse together to form carbon. Carbon then, nuclear fusion, to neon. Neon, nuclear fusion, oxygen. Oxygen, nuclear fusion to silicon. And silicon can perform nuclear fusion until you get to iron. Now iron is the most stable element really in the universe. Once you get to iron, there's nothing left to burn because you can't burn iron. So once you get to iron, the star is out of fuel. But this large star is called a supergiant. So it's not a red giant, it's a supergiant. It's just a larger star. And when we get to iron, then this star is out of fuel. So what happens is all the gravitational forces are going to push inward, collapse that iron core even more. So it's very, very dense, very hot, a lot of pressure, and that pressure is going to be released in the form of a supernova. All of the outside of the star is really expelled out into space. So all the outside gases spread out into space. And that core now is so condensed and compressed. It has such a strong gravitational force that the gravitational force will actually exceed the forces that keep subatomic particles separate. So in other words, the gravitational force is so strong, all the subatomic particles will come together, like the protons and neutrons and the nucleus, the atom, they come together. So that's massive gravitational force. And then in massive, massive stars, all that gravity sucking and sucking and sucking. That is called a black hole. So nothing can escape a black hole. A black hole is massive gravitational force, and that gravitational force is so strong that it actually exceeded the force that keeps protons and neutrons separate. So this is a massive gravitational force in space, and nothing can escape it. Not light, not even you.